If you ask our viewers, what is the largest planet in the solar system? Most would answer at once, without much thought, that it is Jupiter. And they would be absolutely right. But what about the dwarf planets? Which one is the largest? Well, I'm sure, it will take some time to think about it, but still many will answer quickly and correctly. Pluto. But further, to name the second and third largest dwarf planets in our system would take much more time. Only a few people will be able to list, without the help of Wikipedia, at least a few candidates for dwarf planets, but in fact, there are many dwarf planet candidates, and one of the largest such objects, which aspires to try on this status, is Quaoar. No, it wasn't the slip of a tongue. Quaoar was discovered in 2002 by Mike Brown's famous group of astronomers. They discovered almost all the dwarf planets except Pluto and Ceres. Quaoar is some great force from the myths of the Tongva Indian people. So Quasar has absolutely nothing to do with it. Why did they choose that particular name? The Palomar Observatory, where the object was first observed, is located in Southern California, in the territory of these people. Compared to other Kuiper Belt objects, Quaoar may not seem too remarkable. However, it is an important part of astronomical history. Quaoar was the first major object beyond Neptune's orbit that was discovered since Pluto. Its discovery foreshadowed the discovery in the next 3 years of Sedna, Orcus, Haumea, Eris, Makemake, and a number of other bodies. This in turn led to a number of important developments, including the revision of Pluto's status and the current search for Planet X. Quaoar is a trans-Neptunian object. These are celestial bodies that orbit the Sun and have an average distance to the star that is greater than Neptune's, 38 U. Quaoar has a maximum distance to the Sun of 44 astronomical units, 44.896 to be exact. It takes 286 Earth years to complete a full rotation around the star and takes 17.7 days to complete one rotation around its axis, meaning that a day lasts 24 hours for us, but more than 400 hours for Quaoar. The calculated diameter of Quaoar is 780 miles, and the radius is 338 miles. The planetoid follows a nearly circular orbit, slightly inclined, but much more planetary than Pluto. Quaoar's orbit is unique among large objects, which usually follow more inclined and more eccentric orbits. Having a nearly circular orbit, Quaoar is not susceptible to disturbances caused by Neptune, unlike Pluto, which owes its orbit stability to Neptune. As for the composition of this object, everything is very uncertain. There is very little information, primarily because Quaoar itself is poorly studied. Nevertheless, thanks to its passage against the background of a distant star, a couple of years ago, it was possible to shed light on some mysteries of this celestial body. First of all, no traces of an eclipse were found on the starlight curve. It imposes both serious limitations on the size of Quaoar and rather strict upper limits on the density of its atmosphere. After that, an article on the possible atmosphere of Quaoar by a group of American astronomers appeared in the Electronic Preprints Archive. They considered 3 gases that could be part of the atmosphere: methane, carbon monoxide, and molecular nitrogen. At an average surface temperature of Quaoar, about -380 degrees Fahrenheit, gaseous nitrogen and carbon monoxide in balance with nitrogen and carbon monoxide frost on the surface should form an atmosphere with a pressure of about a few microbars. The presence of such an atmosphere would lead to a drop in the brightness of the background star, which was not observed. Thus, the paper's authors ruled out the nitrogen-carbon monoxide atmosphere of Quaoar. The situation with methane was even more complicated. Methane sublimates at a higher temperature than nitrogen and carbon monoxide, and the methane atmosphere, which is in balance with the methane ice on the surface, will have lower pressure. According to calculations, a methane atmosphere is possible at Quaoar. This conclusion is also confirmed by the spectral traces of methane ice on the surface of Quaoar. Finally, in 2007, a satellite of Quaoar was discovered. It rotates at a distance of 9,000 miles over a period of 12.5 days. It was named Quaoar, which, going back to the mythology of the Tongva people, is the son of Quaoar. The satellite has a significantly elongated orbit, and considering the unusually high density of the object, it could have been formed as a result of a collision of a proto-Quaoar with a more massive body. In this case, proto-Quaoar lost its icy mantle, retaining only its dense core, and the satellite was formed from the emissions from the collision. Why is Quaoar, with its sufficient mass and size, still only a candidate for dwarf planets? After all, it was discovered in 2002, even earlier than Haumea. Recall that any celestial body that orbits a star, with the necessary mass to be rounded by its own gravity, but insufficient to clear space around it, is considered a dwarf planet. The object's mass is also expected to help counteract the contraction and set it in hydrostatic balance. Quaoar has the right to be called a dwarf planet. It is a double object, with a density of 2.2 grams/cm3, and a suitable diameter. In general, all this proves that it is a full-fledged dwarf planet. In addition, its mass index for hydrostatic balance is higher than required. So what is the problem? To be honest, I haven't managed to find a coherent answer to this question. Perhaps it is still a candidate because it is very poorly studied and therefore astronomers doubt the parameters, size, and mass that we have at the moment. What do you think? Write your thoughts in the comments. By the way, researchers originally wanted to send New Horizons to Quaoar after the Pluto mission was completed, but NASA said that's impossible because the object is too far from the orbital path of the spacecraft. Today, there is only this image of Quaoar from the New Horizons probe. For now, we just have to wait for new space missions that can study in detail not only Quaoar but also many other objects in the Kuiper Belt.